Hello. So today what we're going to talk about is the final rule for differentiation that you'll be learning this semester in calculus. And what it is called is the chain rule. And it's for taking the derivative of more complicated functions where you actually have a function inside of a function. So the real critical question to be asking yourself now is how do you take the derivative of the composition of functions, such as when f of x equals the square root of x squared plus 2? So you already know how to take the derivative of functions that are just the square root of x. When it's just a singular x on the inside of something, you know how to take those derivatives, but what happens when you have things other than just a plain old x on the inside? That's what this video is going to be talking about today. So the definition for the chain rule is on your screen now. It says if you let y equaling f of u be differentiable function of u, which means that you can take the derivative of y with respect to u, and then if another function u equals g of x, and you can take the derivative of that one with respect to x, then if you compose them with each other, y equaling f of g of x, that's also going to be differentiable with respect to x, and the derivative is one of those formulas on your screen. So if you look carefully here, when you take the derivative with respect to x of f of g of x, what you do first is you take the derivative of the outside function and you leave the inside function alone, and then you multiply it by the derivative of the inside. And the way that it's written down here, with the dy dx equaling dy du times du dx, that's just another way to write it in terms of the product of derivatives. But the first way is probably the easiest way to understand. So let's go through some examples now to see how to actually work. And the biggest tip for using the chain rule is you always want to start from the outside and work your way in with derivatives. So you start taking the derivative of the outwardmost function, leave whatever is on the inside the same, and then you multiply by the derivative of whatever on the inside, and if there's something inside of that, you would leave it the same, and so on and so forth. So you can apply the chain rule a large number of times on very complicated functions. So let's have the first the first example be find the derivative of f of x equals the square root of x squared plus 2. So it might be useful for us to rewrite it as f of g of x to look like our formula, equaling, instead of writing the root, making it an exponent, x squared plus 2, all raised to the 1/2. Where f of x is going to be that x to the 1/2, and g of x is x squared plus 2. So that would be the composition of our functions. So when we go to take f prime of x, f prime of g of x, what we do is we first take the derivative of this outside square root function. So to do that, the first step is going to be to bring down that 1/2 power, and then we're going to leave whatever's on the inside by itself. So we're not going to change anything. So x squared plus 2, and then since we applied our power rule, we have to subtract 1 from 1/2. We're going to get negative 1/2. And now normally in the power rule, this is where you stop. But because we have something here on the inside that has a derivative other than 1, we have to keep going. So now we're going to multiply by the inside of that function, by g of x, the g prime of x. So the derivative of the inside is 2x. And now we're done, because the derivative of anything further on that is just going to be 1. So now we're just going to simplify it, make it a little nicer, and see what we get. So we're going to get the multiplication dot, not a minus sign. So we're going to get 2x over 2 times the square root of x squared plus 2, simplifying that negative exponent. Our 2's are going to cross out here. So our final answer is going to be x over the square root of x squared plus 2. So you're probably still a little confused on the chain rule. We're going to do a few more examples to see how it works on other types of functions. But basically what you want to do is you want to start by taking the derivative of the outwardmost thing, leave everything on the inside by itself, and then multiply by the derivative of the inside. So let's try another example. So let's find the derivative of sine of x squared plus x. Okay, so when we go to take our derivative, we know that we're going to have to use the chain rule because we have a function inside of another function. Because x squared plus x, that's a function by itself, and it's a function that has a derivative that's not equal to 1. So we have to worry about what its derivative is. Have to take it into account. So when I start taking my derivative, the first thing I'm going to hit is this sine function. So I'm going to take the derivative of the sine first. So derivative of sine, we know, is just cosine. And I'm going to leave whatever is inside of it the same. This is especially important for trig functions because once something is inside of a trig function, you can't really change it. It has to stay what that is, otherwise it changes the whole function. Okay, so now that I've taken the derivative of the sine, I can move to the inside and take the derivative of x squared plus x. So now I'm going to multiply by the derivative of the inside. So I'm going to multiply by 2x plus 1 using our power rule. And that's it. You really can't simplify it any further. So we might want to rewrite our derivative just to make it a little nicer. We could rewrite that to be 2x plus 1 times the cosine of x squared plus x. Okay, so that's that one. Let's try one more, and hopefully this is starting to make a little bit more sense. I think we actually have two more. Okay. So for this next one, we're going to find the derivative of f of x equals the quantity x cubed plus the cosine of x all raised to the 12th power. So now in theory, you could multiply this binomial by itself 12 times, simplify it, and then take the derivative using just your power rule and product rule, but that would take a really long time. It would be really labor intensive, and there's a lot of room for error. So what we're going to do is we're going to apply our chain rule to it so that it's a lot easier and there's less room for error then. So the first thing we hit, moving in for our derivative, is the whole parentheses raised to the 12th power. So since it's raised to a power, we can use our power rule. So we're going to bring down the 12. We're going to leave that base of x cubed plus cosine of x to be the same. We're going to subtract 1 from our exponent, so this becomes an 11. So now all we have to do is multiply by the derivative of the inside of our function, so this thing right here. So using our power rule on x cubed, we're going to get 3x squared. And then we're going to have the derivative of cosine, which is just negative sine. So there we go. That's your derivative. So maybe we'll rewrite it to look like 12 times x cubed minus sine, nope, not x cubed, 3x squared minus the sine of x, all times x cubed plus cosine of x raised to the 11th power. Okay, let's see, I think we have one more to go. Yep, so this one is a more complicated function because if you look, we have the sine of the square root of 3x squared minus 2x. So we have a function inside of a function inside of another function. So we have three functions nested inside of each other there, which means that we're going to have to apply our chain rule more than one time. So we're going to go through it just like we've been going through. So first we're going to write f prime of x. Okay, so the first thing I do is I take the derivative of the first thing I hit, which is going to be the sine of x. So derivative of sine is just going to be cosine. Then we're going to leave whatever's on the inside alone. So 3x squared minus 2x. And maybe off to the side we'll rewrite what that is. This is really just 3x squared minus 2x raised to the 1/2 power, just to make it easier when we have to apply our power rule for that. Okay, so the next thing I hit, moving inwards on my function to take the derivative, is the square root function. So now I'm going to take the derivative of that and multiply by what we already have. So taking the derivative of that square root, we're going to bring down the 1/2, leave the inside alone, so 3x squared minus 2x. Subtract 1 from our power, get negative 1/2. And now what we can do is we can take the derivative of the inside. So multiply this again, use our power rule on that inside 3x squared minus 2x. We're going to get 6x minus 2. Okay, so maybe now we can just simplify this a little bit. Okay, so jumping down here, we're going to get 6x minus 2 times the cosine of the square root of 3x squared minus 2x all over 2 times the square root of 3x squared minus 2x. Now you might notice that there is a GCF of 2 in here, so we can actually factor a 2 away from both of these, put it outside, and this becomes a 3x minus 1. So then we can cross out the 2 here and the 2 in the denominator. So our final derivative is going to be 3x minus 1 times the cosine of the square root of 3x squared minus 2x all over the square root of 3x squared minus 2x. So that's a more complicated derivative problem that you might see where you have to use the chain rule a couple of times. Sometimes they get even more complicated where you have to apply the chain rule and then the product rule, maybe the quotient rule, and then maybe the chain rule again. But as long as you stay organized and remember to work from the from the outside in on your derivatives, and then just making sure that you're checking to see if there's any multiplication or division going on, if you can rewrite any radicals to be powers, so you can apply your power rule, anything like that. Staying organized and working slowly and methodically through these problems is going to be what helps you to complete them most accurately. Okay, so thank you so much for watching. I hope this helped. Have a great rest of your day.